Hello everybody. So today I will talk about the system design of LeetCode. And yep, I will start with the functional requirements today. So LeetCode is the coding practice platform where the engineers, or I should say university student, can view the programs, the list of programs, and then he chooses the program and he can read it and code it in the UI editor, and then he can submit the code. He can, code in any language. Yeah, almost any language. And once the code is submitted, in the backend, there is a test cases which are executed on the code. And according to the result, it returns, the status like accepted or wrong answer, memory limited, time limit exceeded are displayed in the UI. Yeah, so that's the LeetCode. And also I will talk about the LeetCode contest in this video. So in the LeetCode contest, there are 4 programs. Okay, sorry. So LeetCode contest is a kind of the weekly contest where LeetCode, provides 4 questions, 4 problem set. Sorry, it's a problem set composed of 4 questions, and users are given 90 minutes to finish it. So they can submit the code once he could solve the question, and yeah, they are ranked, but according to the number of questions he could solve, and also for the tiebreaker, the time he could finish that number of questions. And in the LeetCode contest, which makes it exciting, is the real-time dashboard. So user can view the real-time dashboard where each user's score and rank is listed, and it is refreshed according to the user submission in real time. So these are what I will design in this video. Okay, so as the function requirement firstly, I can say user can see the list of questions problem. Okay, or I should say I will include the search feature. User can search questions with difficulty. So difficulty has hard, medium, easy, enough. And category. So category is like, binary search in graph tree or something like that. And see the list of problems in the UI. Okay, so the next thing, the next function requirement is, of course, user should be able to view each single problem. User can see the problem and can implement the code in the editor. So once he can solve the question, he should be able to submit the code. User can submit the code and get the result. And as I said, the result has accepted, time limit exceeded, memory limit exceeded, and wrong answer. Yeah. And from here, I will talk about the LeetCode contest. So in the LeetCode contest, user can view the list of contest programs I don't include it, and user can submit the code, which is for the LeetCode contest he's participating. And now I will talk about the dashboard. So user can view the dashboard, or just a real-time dashboard, where users participant scores are displayed. Yeah, so this is the function requirement. Okay. Now I will talk about the non-function requirements. So let me get started from the cap theorem. So in cap theorem, so this cap means term consistency and availability and partition tolerance. And the system can support up to 2 of 3. So because we're developing the distributed system, partition tolerance is a must. So I have to choose either strong consistency or availability. So strong consistency is something like when there is a process which reads the data, always it can read the latest data. Latest data means the data which includes the latest update or latest write. So that's the strong consistency. Or availability is the system always returns the data in any time. So if I take the strong consistency, the process can read the data, latest data, but sometimes if the system cannot return the latest one, it doesn't return anything. But if I take the availability, it returns the process. The process can fetch the data always, but it may be outdated sometimes. So when I rephrase this, trade-off in a function requirements, let's say for the second function requirement, if I take the strong consistency, user can always view the problem. But and if the admin user updated the problem description, user can always view it immediately. However, in some cases, user cannot view the problem page. But if I take the availability, maybe user sees a bit outdated description for a while, but even with that, the system returns the problem page, problem statement. So if I compare this, I will go with the availability in terms of the user experience perspective. Yeah, so in the case of LeetCode, it's totally fine that the problem statement is a bit outdated. Rather, user would like to view the problem all the time. Okay. Yeah. So now I will talk about the latency. So there is a firstly search API, search feature, and see the problem feature. For these, I will make it less than 5 millisecond. And for user can submit the code and get the result of the test cases. So it's a kind of tricky. This is a kind of tricky because the time which takes to return the result depends on the number of test cases or according to the problem. So I don't set the specific number here. Yeah. So yeah. Okay. And for the fourth one, real-time dashboard. So okay, I will have something I'd like to discuss here. So real time, does it really have to be literally real time? Or it can be near real time, like the dashboard is updated every 5 seconds. And I can say near real time, like every 5 seconds is totally fine. And it makes the design much easier and system much easier to handle the request, because exact real-time functionality is quite severe and it requires a lot of infrastructure setup or something like that. So I'd like to kind of relax the requirement here, and I will go with the every 5 sec. Okay, and the last one, I will talk about the scalability. Oh, wait, before that, I have something I'd like to guarantee here. So in the third function requirement, user submits the code, but it is possible that malicious user submits the code, which is kind of malicious. Yeah. So in that case, if the security is not guaranteed, I mean, if the security is compromised, that code can do something bad, like reading the database or messing up the system or deleting all the data in the database. So I don't accept it. Yeah. And also, especially in the contest, I need the kind of fairness of the code execution. So let's say there is a user 1 whose code is executed immediately, but for user 2, he submits the code, but his code execution is kind of waiting in the queue, and he has to wait the long time. It's completely unfair, and it doesn't work in the context of the contest especially. So I will guarantee the fairness and security of code execution. Okay, and finally for non-function requirement, I want scalability. Okay. So let's say there are 300k daily active users who submit the code in a day, and contest is, let's say, 10k users, participant in the contest. Okay. So, and one more thing I have to take care is this system has a kind of spike of the write request. So what I mean to say is, in the end of the contest, there are so many users, they rush to submit the code. So yeah. So especially in the last 1 minute, especially 10 seconds, 20 seconds of the end of the contest, there are so many submissions. So I have to take care of this too. So yep. So these are the non-function requirements. Now I will talk about the core entities. The core entities are like the table names in the database. So we have user, and we have program, and we have submission. So I will include the result here. Yeah, and also I will include the test cases in the kind of program, entity. And we need the dashboard, or maybe we need the score. Okay. So obviously dashboard is a kind of, list of users actually. Yeah. But for now, I will make it as a single entity. I will think about it if we really need it later. And for score, so this, I can say this is a kind of list of submission, but yeah, I will think about this later too. Okay. So now I will do the API design. So firstly, I will read the name of APIs quickly. So user can search questions, so we need search API, search program API. And also user can see the program and can implement the code in the editor. So we need get program API. And for number 3, functional requirement number 3, we need the submission API. So here I'd like to call out something. So I said it may take a lot of time until the code execution is done in the server side. In that case, it isn't a good idea that user makes a request and the connection is kept for maybe 30 seconds, 1 minute, and then the backend returns the result. Because if we do that, there is quite likely that the HTTP connection is dead, or lost in that 1 minute. In that case, user have to fetch submit the code again to get the result. So, and he has to try it until it succeeds, which is quite a bad experience. So instead of that, I will use the short polling here. So user submits the code, then the backend returns accepted result, and then the client front end fetches the result maybe every 5 seconds. Yeah. And if the backend has finished the execution, it returns the status, like accepted. If not, it returns kind of pending status. Yeah. So we need fetch result API and submit API. Okay. And the reason why I'd like to use the short polling is, for example, we have the kind of option like WebSocket. But firstly, I can say it is totally fine that there is a kind of 3 seconds of delay until user sees the code submission result. And with that relaxation of the functional requirements, sorry, I should say non-functional requirements. What I should say. So we don't have to use the WebSocket. We don't have to, which means that we don't have to set up the infrastructure. Yeah. So we can do all of them in the HTTP request. And especially I can say HTTP, this short polling, approach makes the HTTP request always stateless compared with WebSocket. So that's why I'd like to go with the short polling here. Okay, so number 5. For this requirement, user can see the real-time dashboard where participant scores are displayed. So the same thing can be said. So as I relax non-functional requirements, what I can do is the front end should, fetch the latest result every 5 seconds. So that's something I can do. So fetch, I would say ranking. So this is the set of APIs I need to implement. Okay, that being said, I will tell about the details. So for search API, search program API, so we need kind of difficulty. And also we have to filter with the category. So we need the pagination here, but I don't talk about that in this video. That being said, this should return the list of problems. One thing I'd like to call out is this API doesn't need the authentication. Even the non-login user should be able to view the program. Okay, and for get program API, so this should be sorry. So it fetches the program from the ID, program ID, and the backend should return the result. And this doesn't need the authentication too. But for submit, we need the authentication. So for each program, I create the submission. So I use the post API. And in the header, we need session token. So with this, the backend can do the authentication and it can know which user ID the request is from. And they should return accepted status. Yep, so in the happy scenario. Okay. But maybe I'd like to quickly mention that maybe it's a good idea that I specify a kind of idempotency key from the client for the case if user pushes the submit button twice or 3 times. Or if we don't want to do the backend implementation for that, maybe the front-end UI should avoids the user to push the submit button twice by disabling the button. Okay, anyway, so the false API, fetch result API. Oh wait, after this submission is done, we need the submission ID. Yeah, and with that, the frontend can fetch the result of that submission. And of course, we need the authentication here. And this should return 200 status. In the happy scenario, this should return status like pending or code, failed, execution failed for some reason, or execution is done and it is accepted, or time limit exceeded, or memory limit exceeded, or wrong answer. Okay, this is something. Sorry, maybe I don't need this accepted status because returning 200 means the submission was accepted. So I don't need it. Okay, and fetch ranking API. So we need the contest ID. And inside of it, it has the nested ranking. Yeah. So this should return. And for this API, we don't do the authentication with ranking object. Okay. So let me quickly make a fix on the core entities. Firstly, I forgot to talk about the contest model. And also, let me rename this dashboard to kind of ranking. So this is something I'd like to update. Okay, so these are the API design. Okay, so I will talk about the high-level design. So in the high-level design, I will implement these APIs, which means I meet all the function requirements here. Later, I will discuss how we can meet the non-function requirements. Okay, so we have the user who submits the code, and I will go with the microservice architecture here. The reason is eventually the system should be scalable, which means that there's so many users and there's so many features. So I'd like to, separate. I'd like to, make it microservice so that I can separate the domain. Yeah. Also, let's say there is a kind of issue in the ranking feature. Even with that, I want the, program submission feature to be working. So for this fault tolerance, I'd like to separate the microservice so that each doesn't affect each other. So being said, firstly, I will talk about search programs API. So for search programs, user makes a request and it is routed by API gateway. So this API gateway does the routing, authentication, and rate limiting. So this the request is routed into the program service. And this program service now makes a query to the database. Let's say programs DB. So it kind of makes a query which filters the programs with difficulty and category, and also with the pagination. So we have the programs database. So it has ID, program statement, and test cases. And what else? Oh, of course, difficulty and category. So maybe category is the list of enum, right? Of course, yeah, one question may have multiple categories, but to make things easier here, I will assume that there is only one category attached to the program. And yeah, maybe these are the attributes. Okay, so now program service makes a query to filter the recode with difficulty and category. Yeah. So that being said, yeah, program service returns the fetch records to the user, and now the list of programs are, displayed in the UI. Okay, the next one, get program. So I will use this program service again. So user makes the request and it is routed into the program service, and it fetches the program with ID. So for this program database, I use the PostgreSQL for now. The reason is because this is the industry standard. I will update this selection if there is a specific requirement to this database, which is not handleable with PostgreSQL. But for now, I will go with the standard. So assuming that I use the PostgreSQL, I put the primary key to the program ID. So fetching the program can be done in the login time. And for the difficulty and category filtering, I use the I create the index so that I can use the B tree. So firstly, I put the index here. Okay, so I have 3 patterns: filtering only with difficulty, filtering only with category, and filtering with both. So for both, I use the composite index. So actually with this difficulty and category composite index, now the filtering only with difficulty that can use the B-tree, this B-tree too. So I need the, specific index only on the category. For the case when the user searches the problems only with the category. Okay, so that's it. So now, composite. Okay, so now, yeah, these first two APIs work very efficiently. Okay, so the third one, submit API. So I will separate the data microservice because as I said, the submission has a spike. So I don't want to affect the kind of temporary issue with the intensive submission. I want that to affect the problem service, problem returning feature. So I use submission service. So user makes the request and it is routed into the submission service. And now what it does is the submission record is created. So I create a kind of submission database. So for this one, this is the create query because submission is created. So submission, we need ID, user ID, problem ID, and submitted at timestamp. And what else? Yeah, okay, I will talk about it later, but for now, submission DB is created. Submission record is created, and submission service returns the success status, which is the accepted status to the client. Okay, so that's the submit API. And for the fetch result API, this is show to polling. So I actually separated because even in the end of the contest, when there is a rush of submissions, submission is the most important thing to be done within the contest time. So I don't want to accept, I don't want the submission result polling API, affect the submission service. So I intentionally separate the server. So this now fetches the submission result. Yeah, so this is it. Okay, so now the problem is who executes the code. So I need the kind of worker who's executed. So one possible idea is using the CDC, change data capture. So when the submission record is created, there is a worker which subscribes the change, submission create change, and it executes the code and updates the result when it is done. So I think it's one idea. Okay. But yeah, I will go with that. Wait, but I think the better idea is kind of using the worker here. So when user submits the code, it is pushed into the queue. Let's say Kafka. Then there is a worker which I'd say execution worker. So now this fetches the submission and executes the code. And now it updates the submission record. But wait, the problem is, what if user makes the request of submission result before this execution worker finishes the execution? Yeah. So when I think of that, I have to create the submission record first here. And then also it dual writes the record into Kafka and the execution worker is executed. But when I think of that, there is a kind of problem like the data inconsistency. So what if submission service creates the submission record, but it fails to create the Kafka record? So sorry. So again, if I think of that, I think the better approach is using the change data capture. So submission service creates the submission record, and there is an execution worker which subscribes the change and execute it in the background. So let me do that. Yeah, in this way, because change data capture record is change data capture is created in the timely order. I mean, order of the submission. The fairness is actually supported already. So this is it. Sorry, so submission record is, so I will abstract the change data capture here. There's a queue actually, and then this worker executed and update kind of status. So status has kind of pending or just executing, or accepted or failed. Wrong answer. So the thing is, so when the submission record is created, it creates the status with, it creates the record with status executing, or I should say running. And then this execution worker subscribes the change data capture, and it executes the code. Then it updates the status. Yeah. maybe it needs test case result. So this can be kind of JSON structure, like test case, input, and result, and expected, result or something. Okay, so this is it. Oh wait, and of course I need the code. This is the real code user submitted, and also language. So which language user used for the coding, like Python. Okay. Yeah, so I decided to use the change the capture here. Good. And now I talked about the until submit API, and also I talked about the fetch result API. And now I will talk about the fetch ranking API. Oh, one more thing I forgot to mention is when submitting the code, it may have to specify which contest it is actually, which contest this submission is for. Yeah, with that, the backend can distinguish the submission for the contest. So now I will talk about the real-time dashboard. So I create contest ranking service. So what it does is, so contest ranking service makes the query to the submission DB, and now this fetches the ranking. So how can I get the ranking? So it makes the kind of complicated query like filter by contest ID. Oh, and I forgot to include it here. So I will quickly write it in the natural language. So kind of filter by contest ID, and also group by user ID, and in the group of user, count unique AC programs, and also get latest earliest timestamp where those number of questions are solved. Yeah, so this is something this query does. Oh, and of course I need to, I have to sort by the count and timestamp. Yeah, so with this kind of query, the submission DB returns the list of users, which represents the ranking. So this is quite complicated, so probably I have to tune it because this query takes a long time, and also this API is called every 5 sec for viewers. But that being said, I satisfied all the function requirement here already. So for now, for today, I finish with this. Okay, that being said, thank you so much for watching. Bye.